Okay, folks, so today, all right, multi-million-dollar room here. Okay, anyhow, we're gonna finish 5.3 and 5.4 today. The math gym, it's open today. They're having these targeted workout sessions tonight from 8 to 9 is online. And after this class, oh wait, this is, I'm in pre-cal, right? Yeah. Yeah, so from 2 to 3 at the math gym, I forget where it's at. It's like the FLN 3.02.08, I think. All right, so you can go by there. They're going over some of the hard web work problems from your homework. I know you need to go by there if you're trying to take the retest, right? Which I think is opening tomorrow. So you have to get your exam corrections done and take them to the math gym and have them check them and upload them before you get permission to take the retest. Something super complicated. I hate. That's the process. Okay. Sometimes this thing is open. They're still hiring more tutors for the math gym. So throughout the semester, hopefully they'll have more and more sessions and times that they're open and stuff. Okay. Or just FYI. So in 5.3, we were down here somewhere. All right, we're going to talk about the period of a function. We're going to briefly talk about that, and then for some reason it's not mentioned again in the entire section. It seems to be ill-placed. So let's talk about a period of a function. So like say a function is giving you the height of the water, right? And the tide is coming in. So like every 4 hours, the tide goes all the way up and all the way back down. So that function that gives you the height would be 4-hour periodic, right? Whatever the height is, if you add 4 hours to the time, you get the same height, right? So if you have something, let's say you graph it. Let's say you have something like this. It just goes on forever and ever, and it's perfectly symmetrical. And in this case, I'm going to call this 2 pi just for fun, right? So you can see that this function from here to here, it just repeats itself over and over again, all right? In fact, give me any x, like right here, this x, all right? If I add 2 pi to that x, I'm over here, x plus 2 pi. I'm still getting the same output, right? So what they mean here is a function is p periodic if it repeats itself. I can add p to the x and it doesn't change the value, right? And that's true for any x. That would be a periodic function. So if you think about cosine or sine or secant or cosecant, these are all 2 pi periodic or 360 degrees, right? Just think about the unit circle, right? If we're thinking about the input as being an angle, right? Cosine on the unit circle is just the x coordinate, right? You start here, your x's go from 1 to -1, and then they come back to 1 again, and then the x coordinates repeat themselves, right? As you go around the circle, the coordinates repeat. That's what a circle is, right? You see the same thing over and over again. So cosine being the x coordinates, 2 pi periodic. Sine is just the y coordinate. Well, the y coordinate here is 0. No, yeah, up here it's +1 up here. Down here it's -1. So for sine, it's the y coordinate starts off at 0, it goes to 1, back to 0, down to -1, back to 0, and then it repeats. All right. And secant and cosecant are just the reciprocals of sine and cosine, so they're both 2 pi periodic. All right. And it's simple. You're going around a circle. Does it make sense? Right. Later on, we're going to graph these, and you'll see it in the graph like this. This is actually the graph of sine. You can see that every 2 pi, it repeats itself. Tangent and cotangent. cotangent are pi periodic. Periodic. There we go. Periodic, right? Why is that? That's only a half a rotation. Okay. Well, let's think about this. Let's see if this is theta and this coordinate is x, y. If I go another pi, so if I go all the way around, theta plus pi, whatever this angle is, if I add pi to it, I'm over here. This coordinate is negative x, negative y. Well, tangent, by definition, was the ratio of y to x. Well, that's the same thing as negative y over negative x, right? You see that tangent of that is negative y over negative x. It's the same thing as y over x. So because tangent and cotangent have x and y in them, you only have to go halfway around the circle before they repeat themselves. All right, that's why. Does that make sense? So we will come back to this later. All right, but just know functions are periodic. Our trig functions are periodic. They repeat themselves, right? Because it's all about circles. Okay. So moving on, we're going to do a couple of examples, just like the ones we did last time. So I think this book needs some revamping. It's just weird. They just throw that in there and then they're like, oh, let's do a problem like we did in the last section here. Okay, here is an angle, here is a coordinate on the unit circle. Find the 6 trig functions. Fine. Cosine of this angle is the x coordinate. Sine is the y coordinate. Tangent is always the ratio of sine to cosine. So it's minus root 3 over 2 over minus 1/2. Minuses cancel, the over halves cancel. So this is just root 3. Cotangent is always 1 over tangent. So 1 over that, which if you wanted to, you could multiply the top and the bottom by root 3. Secant is always 1 over cosine. So if cosine's negative 1/2, 1 over that's negative 2. And then cosecant is always 1 over sine. And so if we flip that dude over, we get this, which you could multiply the top and the bottom by root 3 if you wanted, and you'll get that. Okay. They didn't even tell us what the angle is. We know what this angle is. What is this angle? Right? Based on those numbers, that means this has to be 60 degrees. 180 and 60 means 240 degrees. Or if you're thinking radians, you're like, oh, this is pi over 3. 3 pi over 3, 4 pi over 3. Right? That's what I visualized in my head if I was trying to figure out the angle. Right? If you know the coordinate, you don't need to know the angle to know your cosines and sines and so on. So that's just another example like the ones we've been doing over and over and over again. There's another one. I'm not sure what this has to do with, has nothing to do with periods. So I don't know why they have it here, but here's an angle. Here's the corresponding coordinate. Find our 6 trig functions. Well, cosine is the x coordinate. Sine is the y coordinate. Tangent is the ratio of sine to cosine. You can't divide by 0. So tangent for this angle, it's, yeah, this is what, 270 degrees or 3 pi over 2. This is not, 3 pi over 2 is not in the domain of tangent. You cannot plug 3 pi over 2 into tangent. It will choke because you can't divide by 0. Okay. All right, so cotangent is the ratio of cosine to sine, so that's just 0. Secant is always 1 over cosine, and cosine is 0, so this is undefined. And then cosecant is always 1 over sine, and sine is minus 1, so this is just minus 1. Okay. So that's a real easy one, right? Let's see what do we got here. Here's more of the same boring stuff. Oh, instead of giving us a coordinate, they told us what sine and cosine is. Fine. Secant is always 1 over cosine. So if this is cosine, 1 over that's just 2. Cosecant is always 1 over sine. There's sine, so if we flip that dude over, we get this, which we could multiply the top and the bottom by √3 if we wanted to. Tangent is always sine over cosine. Sine is this guy and cosine is this guy. The over 2's go away. And then let's see, cotangent is always 1 over tangent, also known as cosine over sine, which is 1 over that. So, which we could multiply the top and the bottom by a √3. So, I mean, they didn't tell us what the angle is, but we could imagine it. Let's see, a y value of negative √3 over 2. There's all the y values of negative √3 over 2. But the x value is 1/2. Okay, here's all the x values of 1/2. So obviously, we're talking about this angle, or this angle, or any angle that points in that same direction, right? I mean, what is that angle? We could figure it out if we wanted to, right? To draw it better, we're looking at this basically. So this would be negative 60 degrees. If you wanted to figure out what that angle was. And my drawing is kind of crappy, but let's look at another one. Here they tell us what sine and cosine are, and we know what the rest of them are. Tired of doing these. Here's sine, here's cosine, find the rest. Fine. Secant is always 1 over cosine. So flip this dude over, we get a, remember √2 over 2 is the same thing as 1 over √2. Okay. So 1 over that is just √2. Cosecant is always 1 over sine. So again, this is the same as this. So 1 over that's just √2. Tangent is sine over cosine. They're equal, so it's 1. Cotangent being 1 over that. 1 over 1 is still 1, right? We good? We've done like 800 of these examples. I don't want to do any more. Tired of writing. All right, calculators. Calculators are pain in the butt. They're all different. Plus we have like software, right? We have laptops, apps on our phone. So they're all different. Here they're saying if you have secant of 30 degrees, well, you might look at your calculator and you're like, there is no secant button, and freak out, right? Don't freak out, because this is just 1 over cosine of 30 degrees, and there is a cosine button, right? Of course, 30 degrees, you don't need a calculator. Cosine of 30 degrees is √3 over 2, so this is 2 over √3, also known as 2 √3 over 3. If it's one of these angles that you know, don't use a calculator. Write down the exact answer. If you plug that into your calculator, you're going to get some stupid decimal, and it's an approximation, which isn't revealing at all. You don't learn anything by plugging that into a calculator, right? But some of these problems, they're going to give you like 57 degrees or something like that. For me, I just box that. I say, okay, fine, it's tangent of 57 degrees. That's the answer, right? That's exact. But for y'all, they're going to want you to plug it into the calculator correctly and approximate it so many decimal places. So for a scientific calculator, what they're saying here is this is 1 over this number, and then hit the cosine button, okay? So that's how you would type in a scientific calculator. Graphing calculator, they're just saying here that you could just type 30 pi, and that's the same thing as 30 times pi, right? Why are they doing all that? Well, that's really, that and this, those are both just 30 degrees, right? But they're getting rid of the degrees. They're converting it to radians. Notice the degrees falls out. That's why there's no degree symbol in there at all. The degrees just fell out. So all they did was they converted 30 degrees to radians, is what they did. It's that, or you have to go to the mode and then change mode to degrees, and then you can just type in 30, right? If your calculator's in degree mode, right? But we have software these days. Like I like to use like Wolfram Alpha. Now the thing about the software stuff is it does interpretations. If I want to know what sine of 90 is, sine of 90 degrees, right? This is the same thing as sine of pi over 2 radians, right? What's my y coordinate here? 1, right? This is not sine of 90. You write this, this means 90 radians. I don't even know what the hell that is. That's some weird decimal, right? Remember, 2 pi radians, that's like 6.3 radians goes all the way around, right? So I don't even know where this angle ends, right? So 90 is not the same as 90 degrees, all right? At all. But like this program here, if I type in sine of 90, I didn't say anything about degrees at all, right? But it tells me the answer is, I have to hit enter here, hold on. Enter. Sine of 90 degrees, it tells me it's 1. I didn't put 90 degrees, it assumed 90 degrees, right? So if it hadn't showed me this, like sometimes it doesn't show you this, sometimes it just spits out the answer right here, right? Technically that's incorrect. Sine of 90 is not 1. Yes, sine of 90 degrees is 1, so it automatically threw a degree in there for me, right? So you got to be careful. It's assuming things. Basically, what if I did something like 2 pi, right? So test it out with something you know. What about like sine of 2 pi? Sine of 2 pi, okay? Here's 2 pi. Sine of 2 pi is 0, right? What does this thing tell me? It told me it's -2 times 10 to the -16, right? So the calculator said it's, what is it? 0.0000000 with 16 zeros and a 2. That's not 0, right? That's stupid, right? But 0.0000002, that's pretty close to 0, right? This is why you want to use the unit circle and evaluate these trig functions exactly, because computers do goofy stuff like this. Yeah, for all practical purposes, this is the number 0, but if you type that in and you get this, you're like, oh, and you just write that down, right? It's obvious that you have no idea what you're doing, right? Because it's not that, right? But here's the weird thing. I typed in PI, right? But watch this. If I instead click extended keyboard and I hit the pi symbol, and then I hit it, it says 0. So for some reason, typing PI, it interprets differently than the symbol pi. They're the same thing, right? And this is a very sophisticated piece of software here, all right? So some of these, if I did like 2 pi over 3, because it sees a pi in there, it's going to assume radians. It's not going to think 2 pi over 3 degrees, right? But if I just had 2 over 3, there's no pi in there, it's going to assume you mean degrees, right? So technically, mathematically, that's totally incorrect, all right? But it's a safe assumption because these multiples of pi show up so many times when we're referring to radians, right? 2 pi over 3 degrees is not 2 pi over 3, all right? Likewise, 2/3 radians is not 2/3 degrees, all right? But if you just type this in, it's assuming that, okay? So if you want something like this, you're going to have to like kind of force fit it. So, and every single software program is different. Test it on angles that you know from the unit circle, so you know what assumptions it's making, okay? It's up to you to figure out what software you like to use and how it works, okay? We can't go over a billion different programs in here. All right. So that's enough on calculators. Let's look at, oh, this is just evaluate cosecant of this thing. Again, if this software, I can totally type in cosecant, CSC, and enter it, and it'll be fine, right? But if you're using some kind of crappy handheld calculator, then you don't have a cosecant button. You'd have to do, well, this is 1 over cosine of 5 pi over 7, right? And that would, like, I think my iPhone would do that, maybe. Maybe. Like, turn it sideways, there's more buttons. Yeah, I have a sine and a cosine and a tangent button, right? But I don't have a secant or a cosecant or a cotangent button. We don't need them. The other 3 are just reciprocals of the first 3 trig functions. So I think that's it for this section. Yeah. Did y'all get the sign-in sheet somewhere? Yeah. All right. Okay, learning objectives, blah, blah, blah. Okay. So we're going to kind of go backwards in time now. This is stuff you already know. All right. So if you have a triangle, a right triangle, we call this R, we call this X, and we call this Y because we're on an X, Y coordinate system, right? Sometimes it's inconvenient to use these, right? Remember, sine by definition was Y over R, cosine was X over R, tangent was Y over X, right? But sometimes you have a right triangle that's kind of like this, and here's your angle. And it's like, well, that sucks, right? And it's kind of a hassle to take that and redraw it over here and put it in the XY coordinate system. So what we'll do instead to avoid all that is, well, if this is my angle, this is the side adjacent to the angle. It's the side next to the angle. This side is the side opposite the angle, and then this is the hypotenuse. All right. So these are definitions, right? If you've been in pre-cal before, they might tell you something about SOHCAHTOA to help you memorize these. I can never spell SOHCAHTOA, right? I could sound it out, but if I try to write it, so it's a terrible mnemonic. It doesn't work at all. You just memorize the definitions. From the definitions, I could figure out SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Like if I didn't know the definitions, I could never write that word down. But they're mnemonic in stupid pre-cal classes. They're like, just memorize SOHCAHTOA and then you know the definition. Like, explain the definition, right? Because I can't sound that out. I would spell it incorrectly every time, right? My teacher always told me to sound it out, but I still don't know how to spell the word. All right, that's a joke I can't write down in my joke book. How do you spell that? Okay, so we'll use these, right, when it's convenient instead of these, but they're the same thing. So now we can just skip this section, right? We won't skip the section, but we totally could. Okay, here is a triangle. Find cosine of alpha. Well, cosine is X over R. What is it? It's the adjacent over hypotenuse, right? These are definitions. So adjacent over hypotenuse. Yeah. I don't know what alpha is. I don't care what alpha is. I know what cosine of alpha is. Likewise, sine of alpha would be the opposite over hypotenuse. That's it. Easy. It's from your definitions, right? Right? These were definitions. You have to memorize them, right? And then what were our other ones? We have cotangent whatever you want to call the angle. I like to call it theta. Cotangent was the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite, right? X over Y. Secant, it's a funny C there. Secant was 1 over cosine. Cosine, that one. So secant is hypotenuse over adjacent. Cosecant, what it was 1 over sine. So it's hypotenuse over opposite. Yeah. So these are your definitions of what the trig functions were. There's no way around memorizing that, right? I just memorized the x's and the y's, and then from there I translated to the opposites and adjacents in my head. So here's an example where they drew the triangle backwards. It's like, well, that sucks, but I don't want to have to just redraw the whole picture, you know? Instead, they want sine. Fine, sine is opposite over hypotenuse. Here's the angle, here's the side opposite, and then here's the hypotenuse. Done. All right. Trig function of an angle is always cotrig of 90 minus the angle. So you might have noticed that you have you have your sine, right? And then you have cosine, right? And you have a tangent, and then you have cotangent, and then you have your secant, and you have cosecant. So far, we haven't made any connection between these functions. These happen to be reciprocal to one another, but that's not what this is about. Like, we didn't have any relationship between secant and cosecant, right? Secant was 1 over cosine. This one was 1 over sine. What's the connection here between a trig function and its cofunction? It has to do with complementary angles, okay? Check this out. If this is alpha and this is beta, all right, all the angles have to add up to 180 degrees in a triangle. Alpha plus beta, this is 90, right? They have to add up to 180 degrees. Well, if I subtract 90 from both sides, I got this. So what that means is that alpha is always 90 minus beta, or beta is always 90 minus alpha, right? These alpha and beta are complementary angles. They add up to 90 degrees, okay? Now, check this out. I'm going to use messed up letters here. M, L, and P for the 3 sides, right? So sine of alpha, sine is opposite over hypotenuse, opposite over hypotenuse. Well, let's look at cosine of its complementary angle. Well, cosine, here's beta. Cosine is adjacent over hypotenuse. Notice those are the same thing, right? So if you switch from your function to its cofunction and you switch the angle to its complementary angle, you haven't changed anything, right? But beta is 90 minus alpha, all right? So what we're saying here is take any trig function of an angle, it's always going to be cotrig of the other angle in the triangle. That's why they're called cofunctions. You just, when you switch to the other angle, you just switch to your cofunction. So this is a useful identity, right? This helps you switch between sine and cosine. You just switch the angle to the other angle in the triangle. So all it always is 90 minus that angle. So if this is theta, this angle is 90 minus theta, okay? So that's how these cofunctions work. That's the relationship between them, okay? They're cofunctions of one another. So the cofunction of cosecant would be secant, okay? So I guess I should put like I put a, now this. Dang it. There we go. So now you have 6 new identities to memorize, right? But it's not that deep, right? It's the same concept. So let's look at this. Here's a triangle. Okay, they want all here's alpha. What do you want to know? Sine of alpha. Okay, well, if this is alpha, let's see, this is the hypotenuse. This is the side opposite. This is the side adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so it's 3/5. Tangent is opposite over adjacent, so it's 4/3. Right? There's only 3 ratios, right? That's all of them, right? From here, cotangent, I know it's the reciprocal of tangent. I'd rather do that than be like cotangent, what is it? Adjacent, opposite. Adjacent over opposite, right? It's easier just to go with 1 over tangent, right? Once you know that. Secant is the reciprocal of cosine, so it's 5/3. Or you could be like, secant, by the definition, is, I don't know, secant. I remember secant is 1 over cosine, and I remember cosine is adjacent over hypotenuse, so it would be hypotenuse over adjacent, right? I don't memorize that crap. It's never useful for me, right? I go by cosine, and I know it's the reciprocal of that. I remember what cosine is. It's x over r, or adjacent over hypotenuse, right? And then what's this one? Cosecant. Well, I know it's the reciprocal of sine, so it's 5/4. Let's do it again. All right, again. Same Z. Do the same thing again. I couldn't imagine teaching high school. You do the same lecture like 7 times in a row. I'd go out of my mind. Okay, here's an angle T. Let's see, let's label stuff first. So we don't screw it up, right? This is the hypotenuse. Here's the opposite side, and here's the adjacent side. So sine is opposite over hypotenuse, so it's 33 over 65. Cosine is the adjacent over hypotenuse, so it's 56 over 65. Tangent is opposite over adjacent, so it's 33 over 56, right? Cotangent is reciprocal of tangent. Secant is the reciprocal of cosine. And cosecant is the reciprocal of sine. Right? I'd rather use those reciprocal identities than go back to the definitions that do SOHCAHTOA nonsense, right, for these ones. Okay. Finding blah, blah, blah. I don't know what they're talking about here. I mean, it's true, but I don't understand the purpose. So if this is length S, and this is pi over 3, this has to be root 3s, and this has to be 2s. Where are they coming up with this s nonsense? All right, all they're saying is if this is a 30 and then this is a 60, all right, what do we know about the unit circle? If this is 1, then this is root 3 over 2, and this is 1/2, right? If I multiply all 3 sides by, say, 2, right, that becomes 2, this becomes root 3, and this becomes 1, right? Or I could multiply all 3 sides by s, right? If I do that, 1 times s is s. This would be root 3 over 2s, and this would be s over 2, right? Or if I multiplied everything by 2s, let's see, this becomes 2s. This would become root 3s, and this would become just s, whatever. If you have a triangle, you can multiply all three sides by anything you want to make it bigger or smaller, right? Like I've been saying, if you have our 30, 60, right? If this is X and Y, and this is R, just randomly, right? R, right? You can divide everything by R. So R over R is 1. You get Y over R and X over R, right? So that turns it to the unit circle. Whatever size it is, just divide all three sides by the radius and boom, you're on the unit circle. That's why this is your sine and this is your cosine. Okay. That's all they're saying. Then you could do the same thing with a 45, 45, whatever, right? If you have, this is 1. Remember when we did this, we were like, if this is 45 degrees, remember when we were solving for this, we were like, how do we figure out what X and Y are? We're like, obviously the Pythagorean theorem is true. Oh, and these, since these are the same angle, we know these are true, right? And then we use these two equations, substituting it in, and we solved, and we got X and Y are both 1 over root 2 or root 2 over 2. Remember we went through that whole process, right? Here's a quicker way. Let's see, if this is 1 and this is 1, that has to be root 2, because 1 squared plus 1 squared is the hypotenuse squared, right? By the Pythagorean theorem, 1 squared plus 1 squared is 2, which is c squared. So c has to be root 2, right? So now if I divide everything by root 2 divided by root 2 is 1. 1 divided by root 2 and 1 divided by root 2, right? We could have just started with a triangle where these are both 1. Pythagorean theorem tells us that, and now just what we want is the triangle where this is 1, so just divide everything by root 2. Boop. It's a faster way of solving it, all right? And then, I don't know, they show you this, and then they're like, they don't make any use of it, kind of like the period thing there. They showed us about periods, and then they didn't mention it again. Find the exact value of functions pi over 3 using side lengths. So what they're saying is they want you to draw a triangle. I guess I should draw it to scale, right? All right, so this is pi over 3, and then they want to find sine of pi over 3 and cosine of pi over 3, right? Well, if this is pi over 3, and let's see, I know this is 1, then I know that this has to be a half, and this has to be root 3 over 2. So sine has to be the opposite over hypotenuse, and cosine has to be the adjacent over hypotenuse, right? That's not how we do this. If you want to find out what pi over 3 is, you draw your circle here. If you know the coordinate, you know the lengths of the sides of the triangle. They're equivalent, right? So whichever way works best in your head, right? Normally I draw the angle and then I picture the triangle and imagine the lengths of the sides and boom, write it down. All right. I guess using side lengths, I guess what they're saying is I just chose the hypotenuse of 1, right? What if you had a hypotenuse of S, right? I'd never choose, random hypotenuse, right? I choose the triangle I know. If that's 1, I know what the lengths of these sides are. Therefore, I know my sines and my cosines. I'm not sure what they're trying to get at there. And you can do the same thing for pi over 4. Y'all know how to navigate the unit circle. Here we go. Here's what I told you earlier about the cofunctions and their complements. So now they're going to bounce back to this. I'm not sure why they have this triangle here. All right. Basically, this is pi over 3, that's pi over 6, right? If this is 60 degrees, this is 90 minus 60, which is 30 degrees, right? It's your 30-60 triangle, right? So they're saying that sine of 60 degrees is cosine of 90 minus 60, which is cosine of 30. right? Obviously, right? All you're doing is taking the same triangle and instead of putting it like that, you're putting it like this, right? The sines and the cosines switch. Yeah. All right, there you go. They should have made it skinnier. They should have done something more like that. But anyhow, trig of alpha is cotrig of beta, right? Where beta is 90 minus alpha. And alpha is 90 minus beta. The way it is. Okay? That's just a reminder. Here they are in all their splendor. So they put it in radians, right? Pi over 2 is 90 degrees. All right, so let's do an example. All right, here's sine of t. I don't know what t is. They want to know what cosine of pi over 2 minus t is. Well, this is always sine of t, which they told us is 512. Real hard, right? All right, we're going from the function to its cofunction, right? The cofunction of cosine is sine. Okay. All right, cosecant. Find secant of pi over 3. Secant of pi over 3 is cosecant of 90 minus pi over 3. So if we want to add these, they suck here. Let's see. Pi over 2 is 3 pi over 6. Pi over 3 is 2 pi over 6. So 3 minus 2 is 1 pi over 6. This is the same thing as just cosecant of pi over 6, which they told us is 2. Right? We're just bouncing. If you have secant, you can switch to cosecant, but you have to adjust the angle. You have to switch to the other angle in the triangle. If you want to switch from sine to cosine, just switch your angle to the other angle in the triangle. Okay? Does that make sense? Two angles in the triangle plus the 90-degree one, right? Okay, there we go. Let's look at example 5 here. So here's another sideways triangle. That sucks. Oh, and look, they want us to figure out all the angles and all the sides. They call this solving the triangle. Well, let's see. If this is 90 and that's 30, obviously this has to be 60, right? Because they all have to add up to 180 degrees. Okay, fine. Let's see. If I call this b here, right? I know that a squared plus b squared has to equal c squared, but we know what b is. But Pythagorean theorem, there's two unknowns. That's not enough, right? It's not enough to figure out what a or c is. But we know 30 degrees here. Pick a definition. If it's not the Pythagorean theorem is the first thing that you use, then it's one of your trig definitions. Pick one. Well, sine of 30 degrees is what? Opposite over hypotenuse, right? So there's 30. Here's the opposite side, and there's my hypotenuse. So C has to be 7 divided by sine of 30 degrees, right? We're just solving for C here, right? And I know what sine of 30 degrees is. It's 1/2. So 7 divided by 1/2 is 14. Now that I know what C is, I could use the Pythagorean theorem to solve for A. Or I could just be like, well, fine, cosine of 30 degrees, that's adjacent over hypotenuse. Let's see, where's 30 degrees? Here's my adjacent side, and my hypotenuse is 14. So A has to be 14 cosine of 30 degrees. I didn't screw that up, right? Opposite over hypotenuse. Okay. Adjacent over, yeah. Which we know cosine of 30 degrees is √3/2. So this is 7√3. So solve your triangle. If it isn't the Pythagorean theorem immediately, it's one of your trig definitions is going to break it down. Of course, the WebWorks, they're going to give you like 2 triangles stuck together. So you're going to have to like use like a couple of definitions and do some substitution, but you'll figure it out if you tinker with it. Right? Y'all follow? Here's an angle. We know this. We don't know that, right? Sine of this is this over that. Right? And then solve for C, which is multiplying both sides by C and dividing both sides by sine of 30 degrees, right? I should be able to do that stuff by now. Basic algebra stuff. Are we good? Okay, and then let's see. Let's do another one. Got 4 minutes. All right, so let's see. Here's a triangle, has an angle of pi over 3. Maybe I should draw it like this. Has an angle of pi over 3 in it. Right triangle has a hypotenuse of 20. Find the unknown sides. I'll call them A and B. All right, fine. I know that sine of the angle is opposite over hypotenuse. So therefore B has to be 20 times sine of pi over 3. Sine of pi over 3 is 1/2. So 10. B is 10. All right, now I know this and I know that. I could use the Pythagorean theorem to solve for A, or I could say find cosine of pi over 3 is the adjacent side over hypotenuse. So A is 20 cosine of pi over 3. And cosine of pi over 3 is the x-coordinate. This one's 1/2. I screwed up my sine of pi over 3. This should be √3/2. √3/2, 10√3. Cosine of pi over 3, here's my pi over 3, right? The x-coordinate's the small number, it's the 1/2, so 10. And now we have angle of elevation and angle of depression. I'm not sure why they have these, because they're the same angle, right? Those are the same angle, but they have different names, right? Angle of elevation, angle of depression, right? If you have parallel lines, this and this are the same, right? It's like that and that are the same. But we can find the height of a tree. And I'm not going to make this mistake of using the letter H for the height, because we use the letter H for the hypotenuse. So I'm going to call this L, the length of the tree, right? We're 30 feet away, 57 degrees. So what's going on here? There's an opposite side and an adjacent side. That immediately tells me to use tangent. Tangent is opposite over adjacent. So L is 30 times tangent of 57 degrees. And I box that because that's an exact answer. Of course, for y'all, WebWorks is going to want y'all to plug this into a calculator and approximate it to a certain number of decimals, okay? But y'all can handle that. But that's how you do it. Boom. If it's not the Pythagorean theorem, it's one of your basic. What's up? Hello? No, maybe not. Okay. So let's do one more example. Yeah, here we go. All right, how long is a ladder needed to reach a windowsill? All right, here's a 50 foot above the ground, and we have, here's the length of the ladder, and the angle is 5 pi over 12. Okay, we want to find out what L is. Well, let's see, we know the opposite side, we want to know the hypotenuse. I'm going to think about sine, Why? Because sine is opposite over hypotenuse. So therefore, L is 50 divided by sine of 5 pi over 12. That's my answer. Of course, you'll have to plug that into a calculator and round it off to a decimal, okay? So that's how you do it, right? This is opposite over hypotenuse. It comes just straight to one of your basic definitions, right? It's all ratios. We good? All right, I'll be in my office for a little while. I'll be out of there probably before 3. If you have questions.